We have a couple guests here today. Christopher is this person that I've gotten to know over the past few years, like since the day he was born, since he is my son. This is Christopher Calo. And the reason that I've invited him today is that he's been doing game development for a while. And so he's really worked in Unity. He's played around with a bunch of different stuff and all of that. And I know from just talking to some of the groups this week and all that, there's some of you who have already been working in Unity even before we started this class. You kind of feel comfortable. But a lot of you are kind of just going through the tutorials and kind of stumbling through and just kind of figuring stuff out. So I thought I'd have Christopher come in and kind of give you just some general concepts and ideas to think about when you're working with Unity. And so he's going to kind of show you Unity from a bigger perspective and then kind of drill into some details as well. Some best practices of just kind of using Unity and things like that. And so he's going to kind of show you all that. And of course, one thing he's going to kind of start out, because we ran into it last night, this is not his computer, we were using a different one. And I've told all of you that one of the hard things about being a developer is the fact that your environment seems to change every morning that you wake up, right? There's a new update, there's a new patch, there's something, and you're like, should I click on that? How's that going to ruin everything that I've been working on, right? And that's just the life of a developer, it's just kind of where things go. So he's going to talk about some of that and show you some stuff and tips and tricks like that. Back here is are you his supervisor or? Okay. So Dan back there, he works at Alltech. And he's full-time at Alltech. Christopher is working at Alltech just as a summer intern. Christopher goes to Oregon State University out in Oregon, and they're on a quarter system, so next Tuesday he's flying back home to start classes again. So he's working on his master's degree out there. He graduated here in 2018, we just figured out. So that's kind of where he's coming from. But Dan, you want to come up here for just a second? I'd also like Dan to just kind of talk a little bit for just a couple of minutes before Christopher gets started. And then if he can stick around, he'll be here at the end too. But just talk about Alltech, the kinds of things you do, and kind of job opportunities, internships that these guys maybe want to enter. Because Christopher's doing a current internship. That's what he's doing. And so is that weird guy back there. Chris is also working there. So I'll let you go.
Thanks. My name is Dan White. I'm a development manager at Alltech. I work in the IS department, Information Services. And Alltech, when you think of Alltech, what kinds of things do you know what Alltech is? Anyone here know Alltech? What kinds of things do you think of about Alltech? Power. What kinds of things do you guys? What else do you guys think about when you think of Alltech? Trucks. Yeah. Just trucks. That's the majority. You drive down the road, you see an Alltech truck, right? We're a manufacturing company at our heart. That's what Alltech is. We make big trucks. But the interesting thing about that is that we move into this, now that we're in the 21st century, manufacturing now has a whole dependence upon IS and information services. There's not a part of our process, our business, that is not touched by some system that is in our IS department. You can talk with either one of these guys about the work they've done this summer, is we have so many different touch points that people that are from backgrounds such as MIS, CIS, computer science, they have real value add from day one that they get there, as far as being able to apply creative solutions to some real business problems that we have. I'm a computer science major myself. 25 years ago, I was in a similar place you are. I was up in Indiana, but a very similar situation that you were, and thinking about what does computer science look like in my future. The future is very bright as far as what people that have your background can actually apply, even in the manufacturing space. If you imagine a truck, what it takes to build a truck, there's all kinds of things that take place before the cell that needs to be put into a system. There's things during the manufacturing. There's things after that truck rolls off the line, that relationship that continues on with the customer. Imagine keeping up with the service and maintenance of these trucks, knowing when things break down, knowing when they're using the trucks. Things like that. There's all kinds of interesting little nuances and pieces of data that are being fed into the kinds of things you guys are problems you're solving here. There's VR. There's real VR futures and things as far as virtualization of these trucks to manufacture. There's some interesting problems that are yet to be solved. Some of them aren't even identified yet. And that's what we need people like you that have this good exposure to what is possible. Come up and kind of define what those problems are and solutions for that. Like I said, Dr. Cable said, I'll be around afterwards, I'm gonna hang out here, I'll let Chris ride today, so, I'll be hanging out as long as he's hanging out, and I'll be here to answer any questions you have. But I'll take offers, as these two guys can speak to internships, we have a rich internship program at our NRIS department, and then we look at our job site, there's always jobs out there, popping up in development and other spaces. Anything else?
Cool, for now, guys.
Thank you all very
Thanks,
much.
Appreciate it. And I'll also mention, so like, they're manufacturing companies, so there's a lot of opportunities. That doesn't just mean databases and work with information like that. I'm currently working in C# in Xamarin on mobile development, and there's tons of different projects there. They're trying to get into Internet of Things. And so when you think about Altec as a software engineer, or software developer, there's tons of opportunities, whatever you want to do. So with that, I'm going to get into my presentation today. I know most of you have played around with Unity a little bit this semester. What week is this? Week three, okay. So we're still at the beginning. And a lot of this, if you've been playing around and if you've been watching the tutorials, you may know some of this, but I really want to format this presentation, one, informally, so ask questions throughout, and two, trying to explain good practices, so not just what's possible in Unity and game development. I know you guys are doing more than just games, but basically game development. Not just what's possible, but what are good ways of doing that, what are bad ways of doing that, and how you should approach it. Starting out, I don't see a marker up here. I'm going to write out on a note kind of some of the software and some of the resources that are really good for getting into this. And I'm going to send this to him so you guys can have this if you don't type it down as well. First of all, there's obviously Unity. I hope you guys have Unity at this point. If not, go ahead and download that. There's Unity Hub, which you may not have yet. We can show you that in a second, but Unity Hub is basically how you can keep track of your Unity projects and versions of Unity. Unity comes out with tons of different versions all the time, and it's not like an automatic update to Unity, but it's a new version. And so Unity Hub is a way for you to keep track of the different versions you have of Unity and which versions your projects need to be in. So a project I'm currently working on has a pretty older version of Unity because that's when I started it. And you can keep track of that. Definitely recommend just doing everything Unity related through the hub. I believe you guys already have Visual Studio Code. If not, get that as well. You don't need it for Unity. You can use MonoDevelop, which is a text editor basically for Unity that gives you everything you need. And that comes prepackaged with Unity 3D, so you can get up and going with that. But VS Code, it has a lot of extra functionality. You can make it work perfectly with Unity, and it's a software that you'll probably use later on. So I would recommend using that. And then let's see, Blender. Who's heard of Blender? Okay, a few of you. Blender, for those who haven't heard of it, is a modeling software, so 3D objects. If you want to make like a chair for your scene, for instance, you can make that in Blender. It's a whole lot more, and it can be a little overwhelming to get into it for the first time if you need 3D objects in the worlds that you're making. But if anyone on your teams are interested in that, it's a great opportunity this semester to really get into Blender, making your objects for your worlds in there and then importing them into Unity. As far as a good resource for getting into Blender, and honestly I use him still, even though I've been doing Blender for a while, is the YouTube channel Blender Guru. He's got a new video series that's for absolute beginners. Everyone I think would benefit from it because it's so good. But you can download Blender and start watching his videos, and he's the best resource that I know for that. As far as Unity, a great resource for getting into it is the Unity channel. I don't know if you've mentioned this yet, but Brackness. He talks really quickly in his videos, which I like because you can just open it up and watch it really quick if you want to figure out something like implementing a timer into your scene or animations, and then get back to your coding and your game development. I think he's really good, and I would recommend him, especially since you're just getting started in Unity. Other resources are the documentation on Unity's website. Often documentation is not that great. their documentation is really, really good. It almost reads like a book in some cases. So I would recommend that. And then Stack Overflow is just filled with people asking questions on Unity, so you don't have to worry about that. And then finally, I use YouTube for game development more than I use it for any other type of development or coding in general. It's just so much better to watch a video for something that's visually based. So I would definitely recommend going to you if you have something that you want to do in your team and you're like, I don't know how to do this, I don't know how to implement a timer, for instance. Just watch a video on it. You'll be able to figure out it a lot faster if you can see everything that they're doing than just reading an article. All right, and also I kind of mentioned this beforehand. Please chime in, raise your hand, or talk over me throughout the whole presentation. It can be a question concerning your project for your team that may only apply to your project. It may be a question about virtual reality, which I'm not presenting on right now, but it can be a question on that. It can be a question about anything, and I'll try to answer it the best I can. All right, so with that, again, I'm going to send this to Kaywell. I'm going to pull up, this is Unity Hub. And so what I was talking about earlier is you've got this install button right here. And I've currently got 3 different versions of Unity installed. And if you click on the add button, you can see a fairly long list of different versions, the latest versions. Just download the latest official version. And I would recommend working in that, especially if you haven't done much in your project yet. Download that and open it up in the latest version so that you can make sure you're working with the latest tools. When I opened it up for the first time for this presentation, I was like, wow, there's a lot more stuff in here that I've been using, because I've been using an old version for a long time. And then right here, you can choose which versions that you have installed that you want to use for these individual projects that I have. To create a new one, you may already know this, but for those who don't, you simply hit that new button up there, and then you've got a few different options. You're probably doing the VR Lightweight, which is technically a preview. I've used it and I had no problem with it when I was doing a little bit of VR work. But I will say, from my experience using these different templates, all they are templates. What you get is a Unity project in every single one of them. So you could start out with this template right here and ultimately make a 2D game. Don't use the 2D template, but it's just giving you features that you may want. And if you're just starting out, you could use the 3D with extras, which is just going to give you a bunch of different stuff to play around with. The one I'm going to be opening up, so we would just hit basic 3D, and then we would go ahead and create. Takes a little while, so I'm just going to open up this one that I just created last night and haven't touched. So we're going to go ahead and open that. Any questions so far while we're waiting? Cool. All right. Again, some of you, maybe all of you, already know the basic format of what it looks like when you open it up. But I'm going to go over it really quick just to make sure we're all on the same page. So this is the layout that was probably displayed to you the first time you opened Unity. If you come up to this button up here, first of all, can everyone read this?
It's good enough. They got
Okay.
really nice.
Okay, cool. I didn't want to say that, but I'm glad you said that. So, you can change the layout of the different windows. Up here, you can move these around. I remember when I first started doing Unity, I completely messed up my screen. You can always go up to layers and hit default, which will bring you right back to here. So go crazy with how you want your development system to be set up. I usually take this game icon and trim it down here, and then my development icon is up at the top. But do whatever you want. So first of all, we've got this middle window right here. If you're actually doing anything in this middle window, have a mouse, just because it's so much easier. It's not touchpad friendly. I'm not going to worry about that for right now, but I would recommend having a mouse. If you don't have one, get like a $3 one off of Amazon or something. But this is your scene right here. So you can't see too well in this. You may not be able to see too well if you're far back, but there's grids going throughout here. It's a 3-dimensional environment, and this is where you're putting your objects, you're putting your chair, your floor, your walls, your basketball, whatever it is, into this scene. Over here on the hierarchy is where it displays all of the objects in the scene in a hierarchical manner. And this is, you wanna keep this clean as much as possible, do good naming convention, don't just have something named box, box 2, box 3, or temp, or anything like that. Name it well, keep it in a good order, it'll just make it so much easier for you, and since you're in a team project, it's gonna make it easier for everyone else. And this is where we're going to add objects, and then we're gonna drag them around. This inspector, which is currently empty, when you click on an object in the scene, I'm gonna go ahead and click on the camera. We're gonna see all of basically the settings and what they're called components that have to do with the object. And so if we want to add features to an object in our scene, very often it doesn't require a, thank you, is this on?
Should be green one.
I shouldn't like look.
No, don't look at it.
Is this one of the
Oh, it's
powerful
a
ones?
green one, yeah.
I am. Oh, I'm so glad that didn't work. It's been embarrassing.
What'd you do to it? I just handed it to you.
Oh, there we are. Sorry if I blinded one. It works. So this, the inspector is where you're going to make all of your objects in your scene functional. So all of the objects come with this, I'm just gonna stand up because it's easier, this transform component, which basically explains what it is like in the space, where its position is, what its rotation is, and what its scale is. And then you can have any number of other components connected to that. Often that means you don't have to go into writing a script for your object. You don't have to create everything from the ground up. You can just hit this component button and you get a massive list of different types of components you can add to your object. So what you're looking for may just be right there. You don't have to write a script trying to handle sound, you can just add an audio source. I'm gonna explain the important components, like the main components that you're gonna have to worry about in a second, but I wanna kind of cover the last few bits of the user interface before I get into that. This project is like the File Explorer, also, just like your hierarchy, keep this clean, don't just drop everything into the root, like all of your objects, your audio, your materials that you're putting into your scene. Create a bunch of folders. So in all of my projects, I have a bunch of root folders. I have like scene, sound, animation, objects, and just keep that organized. It's gonna be tempting to just sort of drop things in there when you're playing around, but if you can keep that clean, it'll make everyone happier in your team. Just think of that as a File Explorer, and we're gonna get into that a little bit more. Your console will probably be the tab right next to your project. If you click on that, that's just like the command line. Well, that's really more of the information telling you what's going on with your scripts in the background. So if you have an error in your script, it's gonna appear here. If you have a warning, it's gonna appear here. And if you want to basically print line something to be able to see what's going on, like be able to see what the percentage is of this certain variable, you can print it to here. We're gonna look into that in a second. And then, as I kind of showed you before up here, this is the scene, this is where we can edit. And then the game button with the little Pac-Man symbol is what is actually happening in the game. So if our game was getting played, this is where we would see the first-person shooter, the zombie game, or one of your projects. And then this asset store. I don't know, I'm not gonna get into the asset store that much, but basically if you don't have someone on your team wanting to learn Blender, or if you just need some really basic assets to be able to add to your scene, you can come in here and search for different things. And like, let's see if we can scroll down. Here's a tree pack, a pack of different trees that you can just download and add to your scene immediately. This one's free, a lot of them aren't, but a lot of them are free. So if you're just like, I just want to populate the background with trees, there's a window in the back of this this dance studio, and I want to have some trees in the background. Just download that. No sense in having one of your teammates spend a week modeling something that's barely in your scene. Let's see, is there any other? Then finally, if you can remove any of these tabs by hitting close tab, and then the way you can add it back is you go into window and all of the different tabs are going to show up here. There's a lot more than I've gone over. Most of them you're not going to need, but so if I want that tab back, I can go window, general, scene, and then just drag that scene back to where I want it. So I want it. Okay, so let's now get into components, people are still tracking along well. Okay. So we're gonna add a new object to the scene. Currently we've got a main camera and a directional light, which I'm gonna talk about in a bit. But let's go ahead and add an object so we can look at the different settings and components we have for those objects. I'm gonna right click in the hierarchy. There's a button up here for create, but I'm gonna do the shorter, faster ways of doing things because you're gonna be doing stuff like this a lot. So right click in the hierarchy, you go down to 3D objects, and we're just gonna add a basic object. Again, there's nothing particularly special about these objects. I could start with an empty object and just build up from there. But these are basically templates. These are pre-made objects that will get you started a lot faster. I'm gonna go ahead and create a key. And now you see it appears in the world at the position 0, 0, 0. And so first of all, you can see that it's got a bunch of settings over on the right-hand side, and I'm gonna close down some of these settings because I don't want to worry about most of them. This cube mesh filter and mesh render are basically just having to do with what the object looks like. So this is what makes it a cube, essentially. We're not gonna worry about those. If we deactivated the mesh render, the object would not be seen in the scene. But we're just gonna leave them as they are because you're not gonna have to touch them very often. The first component, as I mentioned, is the transform. If we change variables in here, we're changing what it looks like in the scene. This is rotation, and then scale. They all work as you may expect. I'm gonna undo all of that. And that's, when you're doing game development, these transforms can get pretty complicated. Thankfully, Unity helps us a whole lot. If you were writing this all in code, like in an OpenGL library system, you would be multiplying transforms and vectors, and it would get really complicated. Unity handles a lot, but it's still one of the first things you need to start getting into the mentality of is operating in these 3D environments based on an X, a Y, and a Z. That's not just for position, that's also for rotation. As you can see, it's scale. Directions are vectors, are often handled by creating a vector, which is just like one of those errors with lengths. And so get into the mentality of these vectors, these vector threes, which is just a 3D vector with three different, with an X, Y, and Z, and then how to multiply them, how to add them. It may get a little frustrating when you first get into these transforms, but it's gonna make more sense as you go along. And watch a YouTube video if it's confusing. Now, this box collider, that's already added for some of these objects, but there's a bunch of different colliders out there. If I type in add component and then type in collider, you'll see there's capsule colliders, there's mesh colliders, which are colliders that match the exact shape of your mesh. So if you had a chair, a mesh collider would be a collider in the shape of a chair. And basically what colliders do is it allows your objects to interact with other things in the scene. So if you're adding an object to your scene and you want it to in some way be able to interact with other things in the scene, which isn't something you always want. If you want it just to be in the background, you may not want that. But if you do want an object to interact, add a collider of some kind to it. This is a little tip on how to keep your scene as CPU, as not CPU as intensive as possible. Use the most simple collider you can. So if you've got a tree in your scene, a mesh collider is going to be a very complicated thing for the computer to render because it's going to have to render all the leaves and the stems and everything. If your character, like if it's a VR world, the character's not climbing trees or anything, just put like a capsule collider around the base of the tree and don't create collision in the top of the tree. If they were to jump over the collider, they could walk straight through the tree, but that's fine. Just make it as simple as possible. Making colliders actually collide is a little tricky, and I'm going to explain that in a second. But first I want to introduce another component that's important for these kind of things. First of all, are there questions on the collider or anything? Okay. The next component you're going to be using a lot is a rigid body. Rigid body is basically when you want physics to interact. You want this object to interact in a physical way. So colliders are when you want things to interact with each other, but that's not necessarily in physics, having to do with physics or Newtonian physics or anything like that. Rigid body has all of that built in. You see there's mass, there's drag, angular drag, if it should use gravity or not, which is automatically checked. And so if we add a rigid body to our object and we hit play, which will bring us over to the game tab, you'll see that it falls off the scene. Side note, if you go to the game tab and hit this maximize on play button, then when we go ahead and hit play, it will take up the screen and give you a better understanding of what the people playing will see. So, and then if we turn off that gravity, it's not going to fall, but it's still going to be interacting. Basically, if another object hit this, it would act like it's in outer space because it's still a physical object. Now, the reason I introduced rigid body right after box collider is because to make collision actually work, one of your objects needs to have this rigid body component. And if we want to turn our box collider into a trigger, which is basically, it's not a physical object, but it's an area that is sensing if things are entering into it, like a portal, or if you want your character, you want music to play when a character enters the scene, you just put this big trigger on the scene so when the character walks in, it plays. If you want it to not be physical, you can turn it into a trigger, and that'll work. They won't collide into each other, but it will recognize its presence. And I'm going to demonstrate that in a bit if that makes sense. But basically, to make collision work, both of the objects that are colliding, interacting with each other, need to have some sort of a collider on them, and then one of them needs to have a rigid body. Some of you may have figured that out already. It took me an annoyingly long time to figure that out, because it seemed weird. But both need some sort of a collider, one of them needs to have a rigid body, and then collision will actually be recognizable. Because if you're trying to recognize collision and do things in code, if things collide, one of them doesn't have a rigid body or one of them doesn't have a collider, it's just not, that code isn't going to fire, it's not going to recognize. It's not going to give you errors or anything, it's just not going to happen. So make sure you have that set up. A good rule of thumb to recognize is, because the question is, so which one should have the rigid body? The one that you expect to be moving around in the scene should have a rigid body. Even if you have gravity turned off and you have kinematic on, which means it's basically an immovable object, things hitting into it isn't going to hurt it. Even if you have those settings and you want to control how it moves, not in a physical way, put the rigid body on the moving object. Unity, underneath the hood, expects any objects that are moving to have a rigid body. And so if you've got like a wall that you want to be able to collide in, it doesn't need a rigid body, it's just sitting there. And then the character has the rigid body, and so it collides. If you have like two basketballs, both can have the rigid body and they collide just fine. And then if you check this trigger box, it's not going to collide into the wall, it's going to fizz right through the wall, but it's going to recognize that something has passed through the wall.
Can you point where that trigger is? It's kind of small.
Oh, yes. So inside of the collider component, right there, it will be off by default, and then just turn it on if this is not, if you're not thinking of this as a physical component, like if you're creating a portal in your world that when the character walks into, they teleport to a different scene. You want the trigger to be checked so that the character is not just hitting into the portal. You want it to be an unphysical object that can pass through and go to the other scene. Now, another good tip, because I really want to cover things that I kind of learned the hard way, like naming conventions, stick to it even if it's annoying, colliders, how they work. Another thing is prefabs. So prefab, I think it stands for prefabricated. It's basically it's sort of like a class or more like a blueprint. So let's say over here we've created an object and we've made it a more complicated object. It's got these, it's a nested object with an object inside of it, and so it's maybe like our main character, like this. And then we've added a bunch of components, added some scripts to it, added some coloring to it and everything, and now we want to have a lot of them in our scene. In my case, I'm making a game with spaceships, and so I have a lot of spaceships flying around, and a lot of them are the same thing. One thing you could do is like copy and paste this and just have a bunch of these cubes in here. But Then you go to your next scene, you've got to copy and paste those into your next scene. And what if you want to create an object dynamically? So your scene has started and then you want a spaceship to come into the scene. Well, you can't be copying and pasting at that point. It's got to be instantiated into the scene. Don't keep complicated objects just sitting in here. When you've created something that you don't want to create another time, that you think you're going to be using multiple times, grab it and drag it down into your file explorer. You'll see that it turns blue up here, which means it's an instance of a prefab. And if I make changes to this object down here, we're going to see the changes happen to any instance of that prefab. So I can just drag this up here and have a bunch of these. And if I make changes to the version of it inside the file explorer, those changes will be added to those objects. One thing to be aware of, if you're making changes to just one of these instances, it's not gonna update all the other ones. Instead, so like if I hit use gravity, it hasn't changed it for all of those other objects. What you have to do is you've got to come up, so with a prefab, you've got these options up here. This overrides button, you click that, hit apply all, and then that's going to update every version of that prefab. You make the changes just in here, you don't have to go through that process of updating. But if you, for some reason, are doing it up here, you make your bouncy ball green instead of red, and you are like, oops, I should have done that down here, I should have made the change to the prefab itself, not the instance. Hit the overrides, apply all, and it will apply to all of those. Did that make sense? Do I need to go through that a bit slower or anything on that? Because it's something you're going to use, or you should use. There should be blue in your hierarchy when your scene gets complicated. It doesn't need to only be blue. Like if you have a ground in your scene, and the ground doesn't get destroyed, it doesn't show up in any other scenes, it's not complicated, you don't have to make a prefab of that. But it's never wrong to make a prefab of something, so just err on the side of, is this something complicated, is this something I may need later, I'm going to make a prefab of it and then just put the version, then drag this back up into here and do it that way. All right, let's see. What do I want to cover? I can't get into code. Oh yeah.
Would you normally leave those prefabs just out in your assets, or would you create separate folders within? How would you organize it?
I would create a separate folder. So if I right click down here, hit create folder, and then that's a good point, because one of my base folders is always prefabs.
Okay.
And then I put it in there, and then even in there, I'll separate the prefabs into different ones, because you're gonna have a lot if the scene gets reasonably complicated. So you may have background prefabs, you may have characters. So yeah, that's a good point. My rule of thumb, and then I just drag it into the prefabs folder. My sort of rule of thumb is to have nothing but base folders in here. All of your objects, there shouldn't be any just random objects or sound bites or textures or materials sitting inside of here. They should all have their own folder. And if you create something that doesn't have a place for it, create a new general folder for that, because you may have more. And then that gives you an understanding of where it is, and it helps your team know where everything is. Good point. Okay. So another thing that gave me a huge headache, even actually last year, as I was making the game I'm working on right now, is layers. So layers are how you can split up your scene into different types of components. If you've used Photoshop or a piece of software similar to that, you may already know the concept of layers, where different kind of things like foreground, the background are in their own separate layers, and you can edit them against each other. So Unity also has a concept of layers, and you'll want to be using it especially if things are colliding with each other, or interacting with each other, but not everything is interacting with everything else. So for instance, if you've got a first-person shooter game, you may want there not to be friendly fire. So you basically want no interaction between friendly bullets and friendly players. But you do want those bullets to interact with opponents. So now you're in a situation where you've got this bullet object, this friendly bullet object, that does interact with certain things in your scene, but not other things in your scene. That's where layers come in, and you're probably going to have, or probably should have layers. You should create a list of layers. You don't have to create this on the outset, all the layers you expect in your scene, but create them as you're starting to see, okay, I want this thing to be able to interact with certain things. I want this ground to be able to interact with the wall, but not the bubbles, or something like that. The layers, or the current layer is shown up here at the top of the components list of the inspector of each object. And how we set it to a different layer, it's currently set to default, is we click on that, and then we get a drop down of the different layers. Currently there's like transparent effects, ignore raycast, water, UI. I use some of those, but you can create your own. So if that doesn't apply, just add a new layer, and then you get this massive list. And I guess you can have as many as 31 layers. And so let's just create a new one. Let's call this background. And then it's annoying, there's no way we can actually set it from here. So instead, once we've created this new layer, we go back to the object. And then when we do this drop down again, we're going to see number 8 is the background. And in your code, you can reference the layers either by typing in a string with that name background, or you can reference that number. I recommend the number just because it avoids type errors. The default is always 0, and then anything you add is 8 to 31, or to 30. And then it's just prompting me, do I want to change the layers for all of the children for this object? And I'll click yes. And so I'm going to go ahead and just add a bunch of different layers to give you an understanding of what your scene may be like. So your background may not interact with anything. Then you've got ground. You've got friendlies. So those are the, if we're continuing with this example of like a maybe battle royale game, you've got friendlies, you've got friendly bullets, and so on and so forth. And then I'm just going to add enemies, and then enemy bullets. I'm just using this as an example. You don't have to do this exactly. Like I said, usually I wouldn't do all of these on the outset because you're not going to know the different ways things are going to interact in your scene from the outset. It's sort of more of an art in this case where you just sort of figure it out as you go. It's like, okay, I've got a bullet, but I have 2 different types of bullet. I've got the friendly and the enemy. I use this example because this is something I'm running into with my little spaceship game. And so now we've got a few different layers. The way we decide how they interact is we go into the edit option at the top, down to project settings, and then down on this side menu, go into physics. And at the bottom of physics is a really weird graph that shows all of the different layers that you have. You'll notice that default is at the top. Those ones that we were ignoring are right here, and then background, ground, friendly bullets, enemies, enemy bullets. And you simply just go through here and think, do I want these to interact or not? If not, I'm going to uncheck it. I think so let's say we want background to not interact with anything at all. So I'm going to go into background, and I can just basically uncheck all of this. Because I want nothing to interact with the background, I just want it to be stale. In my scene, I'm actually using default as the one that doesn't interact, so I just uncheck all of these at the very top. But I think it's probably a better practice than what I'm doing, is to have your own. And then you go through, do I want friendlies to interact with friendly bullets? No, so I find the box where those are crossing. Friendly bullets with friendlies is now unchecked. And err on the side of turning things off. It comes with all of them on, but it's better to just have these off and then turn on the ones that you do need, just to keep interactions that you don't want happening from happening accidentally. I was running into this and I didn't realize my issue was here, and I was wondering, why is my main character exploding every time he tries to shoot? And it was in here, so I had to go in here and change all of that. So that may seem like a weird thing for me to harp on with all the different Unity stuff, but that's very important. My game is 2D, but it's just as important in a 3D game or virtual environment.
So what if we do want to friendly fires, but because I want to do a less damage, because you shoot. Because I want to do less damage, but I still want to have friendly fire.
Okay, So if you have certain things that you want to interact in different ways, is that kind of what you're talking about, where you want friendly bullets to interact in different ways when it touches a friend and an enemy? I'm gonna get into that when I go into the scripts right now, but basically, you keep it on so it can interact with both friendlies and enemies. And then in the specific Unity method that handles interactions, you say, if this is a friendly, if we've just interacted with someone who's on the friendly layer, we do this certain thing. If it's an enemy or otherwise, we do this certain thing. Does that make sense? Cool. And before we get into code, I will mention one other thing. There's layers, but there's also tags. They kind of interact, they kind of are similar to each other, and it's sort of up to the developer to decide how you want to work with your tags. But I tend to use tags and layers in very similar ways. The one difference is that layers have that component where you can check and uncheck the will there be an interaction, will there not. But your tag is sort of like if you want a cluster of objects that are similar but have different names, so you don't want to be referring to them by their name while you're scripting, you can give them all the tags. So we could instead say, if there's no need for a specific layer for enemies, for example, we could just create a enemy tag by coming in here, enemy, save. Annoyingly, we have to go back and click on the object. It's a first world problem, but it's kind of silly. And then we can go and change our tag. After we added a tag, we can change our tag to enemy. And in the script, you can basically type the object you're on dot tag equals enemy, then do this, otherwise do this. Again, it's very similar to layers, other than it doesn't have that one component. So just use it as you think best, and always be aware of it, because you may run into some situations where it makes more sense to do tag and to set tags instead of setting specific layers. I can't explain certain situations where that may arise, just because it's really a case-by-case situation, but just be aware of that. All right, so I'm gonna delete most of the objects in the scene. And I've got some stuff I can talk about in audio and lighting, but I'm first gonna get into scripts, because though you can do a lot of stuff outside of scripts, you're not gonna really be able to make a game if you're not writing code for Unity, which was my problem because I didn't know how to code when I first got into Unity. So we're going to go ahead and do that and talk about that a bit. So we've got our object right here. It's not a prefab, that's fine, it's not complicated yet. And basically, we want it to move back and forth when the player gives input. So I've currently got a game where it's a 2D game, sort of like Galaga, where there's a ship down here, and that's the main character, and all the player has is moving back and forth when they press the two arrow keys. And so we're going to do that first, because character movement is something you're going to have in most everything. I know VR, character movement works differently, but you're going to have other objects that move. So I'm going to click on this object, either in the hierarchy or in the scene. I'm going to go to add component, and we're adding a script to our object. And we're just going to type into this add component box what we want the script to be. Let's just call this player. I'm going to call it player move. And then you see my one option is everything else has disappeared, and it says right here, new script. And if I click on that, it's going to give me the option to create a new script and add it to this component called player move. Now when I create this, the script is going to become a new component of this object. So any code I put into that script is going to apply to the object. And it's also going to appear here. So another folder you're going to have is scripts, and that's going to get pretty crowded too. All right, and there it is, and it should appear on this object in a second. Player move. And let's just open that up. And if you're not opening it up, you can just look at it over here and see what it looks like, just to give you a quick glance without having to open it up. I used to use Visual Studio with Unity, and Brackeys, the YouTuber I recommended, he does that as well. I really don't recommend actually using straight up Visual Studio for programming in Unity, because you're going back and forth between Unity and your script a whole lot. And it's just a slower software than you need. to be able to do that. Visual Studio Code, ironically, which is not open right now, is a lot faster than Unity, and then Visual Studio. Okay, I'm gonna go ahead and open it right there. See if double clicking. Brings it over.
May not be associated with it.
Yeah, well, I think it did work earlier. Instead, and I've had this problem before, if it's not on network, it won't open up Visual Studio Code for some reason. Instead, I'm just gonna go into Visual Studio manually, open up a folder, and then go into my game project, go into assets, which when you're working in actual File Explorer and you open up your project, it's gonna look different than the File Explorer in Unity. But here, this is what's going to appear, and basically all you care about is what is the assets folder. All of these are sort of have to do with the back end of your project. If you open up assets, then it's going to show you those folders we created. You see scenes and prefabs, which are the folders we created. And so I'm just gonna open up this one, and we should see a script. Yes, there's player relief. Usually if you just double click it in Unity, that'll open up, but that's another way of pulling it up in Visual Studio. So the first thing you see, that's small. How do you make text bigger in VS Code? Is it preferences? Oh no, wait, I think it's just,
There's a key command. I
Yeah,
don't
there
know what it
is.
What is it?
There we go.
Control plus.
yeah, I got it. Is that
Library
better?
Explorer.
Is that better? Do you wanna turn off the middle light? Or-
No, that's fine.
Okay. So this
I
is
can
what
see
your
it,
first.
they can see it.
Okay. This is what you're gonna see. This is the basic script that is created for any script that you make in Unity. These are imported. This Unity engine is what gives you the ability to edit and modify Unity-related classes and variables, such as the game object you're on, those layers, those tags we were talking about, and the components, which we're going to see in a second. This is your class. One side note really quick. If you're, I guess everyone here is doing Java or has done Java for a while now. C#, if you haven't done C# or if you're just getting into it, it's virtually the same, especially as far as Unity is concerned. I remember when I started with C# specifically for Unity, and there wasn't a learning curve. So there will be a few things that may be different. C# tends to give you more, which is really nice. But don't freak out about having to learn a new language for this class. It'll carry on with what you've been learning for Java. So we've got our public class, which is the name we gave the script, and this mono behavior. So this is, remember, this is an extension of mono behavior. We're extending the class features of mono behavior, which means we can have certain things like getting the component references of the object this script is on, getting references to the object itself, and different Unity-related stuff. If we remove that, this would simply just be another C# class, but this allows us to interact with the Unity object. And then it comes with these two basic methods. Unity has a bunch of different methods that are built into it, and I'm gonna show you one or two other ones after these. But basically, these are the ones that you're mainly gonna be interacting with. You know your main method in Java, you won't see any main methods inside of these scripts. Instead, you're going to see the Unity provided methods that you're going to be writing code in, and ideally writing methods that are called in those scripts. Just like you don't fill up your main method, you write other methods and they're called in there. The first one, start, void start. It is called the second the object is created in your scene. So if we have objects at the beginning, when we run that scene, this is run once at the very beginning of the scene for every object, and then it isn't run again until another object is created and its start method is run. Update is what you're going to be putting a lot of code in, and you want to keep it as minimal as possible because there's going to be so much stuff getting put in there. Update is run every time a new frame is rendered on the screen. So it's going to be roughly 60 times a second update is run. We're going to be putting our code, remember the moving back and forth code, we're going to be putting that in here. It is not called 60 times a second, it's called roughly 60 times a second. And that's important to know, and it varies second by second. It doesn't affect you hugely, it affects you in a little bit that I'm gonna show you in a second. But if you need a method that actually literally is called a set number of times every second, then there's a method called fixed update. And that's basically what it does, it's consistent and you can rely on its consistency.
Did you say FIX update?
Yeah, I think I can actually show you. Fixed update, there it is. And it says right here, this function is called every fixed frame rate frame, if the mono behavior is enabled. Basically, that's saying what I just said. It's actually recommended, almost always use update, but it's recommended to use this if you're dealing with physics. If you're doing stuff with physics in Unity, it's recommended to use that. I'm not sure why. You're probably not going to be using fixed update, but it's good to know it's there. Also, there's another similar method to start called awake, which gets run right before start. You may not be using that either. You could use start, and you could use awake and not start for initializing stuff at the beginning of the object's lifetime. The big difference is basically awake is called when the object is enabled in your scene, and start is only called when the object is created. If that doesn't make sense, just use start, and if you think you're in a position where start almost works but doesn't quite work, look up the Unity documentation on awake and it will give you a better understanding of how that works. So right now, update is really all we need to be able to do our functionality. Update is called once, or a bunch of times every second, and so if we have things moving through our scene, if we have something gradually changing, like a character moving through the scene, you put it in an update. So what we basically want to do is we want to check to see if the player has pushed a specific key, and then we want to do something based on if that key has been pressed. Usually I would put this in its own method and call it an update, but since it's really simple, I think it's alright to just put it right here. But usually you would want to implement better coding standards. So we're going to type in if input dot get key. If input dot get key, and it also side note, I know I keep jumping off, but I keep remembering things that you'll want to know at this point. If you're going to be using VS Code with Unity, go into this little extensions button, and then add the different components that you see that will help you with Unity development. They do different things, so there's a debugger for Unity, there's this mono behavior extension that'll give you suggestions of the different options you can have. So when I type in fix update, it had a bunch of different options. Unity snippets, which does similar stuff. Just go through the different Unity related extensions and see which ones will do what you're trying to do.
Can you include that in your list that you send to me?
Yes, yes, because there are a lot of them. It can be pretty finicky how to get that working. But right now, because I opened it out of Unity, I'm flying a little bit blind because I don't have those tools. And it's far better to actually have access to when I start typing input, it says input is an option and get key and get key down are options. That's the one thing about using Visual Studio Code instead of Visual Studio. It requires a little bit of setup to make it a good Unity environment, but once you get it set up, it's just as good and then it gets better. So if input.getKey, what key do we want to get? Key code dot write arrow. So this is basically saying we're looking for input. If the key is pressed, then if this key is pressed, this right arrow key is pressed, then we're going to run this code. Otherwise, we're going to skip it. And just to make sure it's working, and really to introduce you to debug.log, we're going to throw a message to the terminal if this runs. Debug.log is another tool you want to be aware of. I do recommend using this debugger for Unity. but basically it's your print line, system.out.println for C#. So now that we've got that, we've saved it, I'm going to go back into Unity, and at the bottom you can see this tiny little symbol, loading symbol that just went away. That happens every time you save a script and go back into Unity. It has to quit compile again. If you've got an older computer, this could take a little while. A newer one, you can see that went pretty quick. So now I'm actually gonna go to the game tab, turn off maximize on play, and then I'm gonna open up my console down here. And when I hit play, and then press that button, you can see a bunch of hello worlds appear because I held it down for a little bit. But that just shows us it's working. So that's good. And this just, there's our message right there. This is when it happened, and then this is what made it happen. I'm gonna stop that now, and then I'm gonna go back and do it. Great, that's working. I'm gonna comment that out by hitting Control-KC. Good little keyboard shortcut to be aware of. And then we're gonna, now that we know it's working, we're gonna implement our code into this. So first of all, I want a reference to the object's current position, because basically what I'm going to do in my code is say, where is this object right now? Move it a little bit to the right every frame that this key is being pressed. And then what we'll see is just a continuous stream of it moving. So what I first need is a reference to these values. These right here inside my script, so I can manipulate those values and make it basically do this when I press the key. Change the X value. So first of all, I'm going to type in this, which is a reference to the object, basically. Get component, and we're going to do diamond brackets. It's kind of a weird format to remember, but you're going to be doing this a lot because you're going to be referencing the components of this object or other objects in your scene a whole lot. And then the name of the object, not rigid body, I'm sorry. The name of the component, which is transform. And we know the name of the component, if we come in here, it's right up there. And it will always match that. So transform. Close the diamond brackets. Empty parentheses. I think sometimes they're not empty, but in most every situation, if you're just trying to get a reference to the component, then empty parentheses. Now that is a reference to that component, and if we want to get access to the variables, we can do the dot notation and then the name of the variable. So we know one of the variables is this position variable, which has three values, the x, the y, and the z. Oops, my bad. And so that's how we reference that. And we're just going to assign this to a local variable so that we don't have to keep writing that every time we want to get access to the position. So I'm going to create a vector 3, which is, I believe, something specific in Unity. It's just basically a an array with length 3 is how you can kind of think about it. Unity looks at it differently, but it's basically just got 3 values, x, y, and z. So we're going to create a new one, call it pos for position, and then set that transform value to that value. Since we're doing this on the update every time, this value is going to be different for every update, because we're getting the component every update. We're referencing its current position for every update and then setting it to this new variable. You can kind of think of update as a loop, where this position is changing every time we go through the loop. And so now that we have that, we can actually change the position. We're going to have to reference that component again, because now this vector 3 position is disassociated with the actual position of the object. It's just a local variable. So we're going to have to reference this position again if we're going to want to set it to something else. A good shorthand of this ugly monster for transform is just this dot transform, lowercase. I think you can leave off of this, but I recommend always putting it in there just to demonstrate, because sometimes you'll have other objects in the script and you want to make it clear that the transform is referring to this current one. So this dot transform does the same thing as this dot get component transform opening and closing parentheses. And so we can then get the position and set that to a value. If we did this, and I'm gonna type it out really quick, cost.x, cost.y, cost.z. If we did that, we're basically setting the position to the current position. You can see how that's working. With position equals the values of the current position, and then we're just setting it back, basically. What we wanna do is we wanna do this, create this new vector with those locations, and then just change it a little bit along the x-axis. And so we're just going to add to that variable some value. So this would make it move along in the scene, because every time we're taking its current position and adding a little bit and moving it in that direction.
So is that an addition symbol?
Yes, that is, yeah, that's position.x plus 5. I can make that a little bigger.
Yeah, that's right.
Actually, this would work, but this is not gonna work as you think, because remember, update is not being called a fixed number of times every second. And then you could do the fixed update, but some computers run faster than others. So this would lead to some people in your world with really powerful computers are like sprinting along the game, while people with a slow computer, like my Surface Pro, would be moving very slowly, because the update is being called fewer times for the person with the slower computer than it is for the person with a gaming laptop. So this is not going to work. We need to do a small change, which I'm going to type and then I'm going to explain. This is important to understand. You're going to want to do this every time you're moving something along the scene that you want it to move at a specific rate. I'm going to do 5, so I'm doing parentheses 5, whatever our speed is. This is just 5 was just a speed I chose. Times time, capitalized, dot, lowercase, delta time, and then closing parentheses. So this is basically our x-axis offset. What time.delta time does is it's basically the change of time since we last called the update function. This is where what I'm talking about, where it can get a little complicated dealing with these transforms and vectors, but you kind of want to just get used to it. If we multiply our value by time.delta time, then everything's going to be consistent, because if we're calling update only a few times, time.delta time is going to be a bigger value because it's been a longer time since we've called that. If we're calling it a whole lot of times with our gaming laptop, this is going to be a smaller value. So ultimately, the final conclusion is the object is moving through the scene at a consistent rate no matter how fast the computer is going. Always add that in situations like this, and you'll be good. As long as you're dealing with movement, that's what you want to add. And if you go online, and if you probably type in time.delta time and search in the Unity documentation, it will explain that and explain other situations in which that works. So basically, if the key is pressed, we create this pos variable, and then we set the position to that position variable with a small offset. And so now if we save this, paper name space name cannot be found, and see, this is what I was talking about earlier. Have this always, you can, if you have the project open, down in the bottom, the latest error or message will show up, which means you want to go into the console and see the errors you're seeing. Usually I wouldn't get this because VS Code would be telling me about these errors, but because I opened it outside, it doesn't have those. So let me go ahead and open that up. Position,
Is it because you did pos and US dot Y the N in the C position, or
say that again?
did you did POS dot Y twice in the second line?
Oh, yeah, and your transform position.
That's not why, no, that is a problem, you're right, that's not.
No, I think it's transform. You don't have to add in the middle of your transform. You have transform.
Oh, really?
Yeah.
Oh, yeah,
you're
that
right.
same line, go to the
You're
beginning
right.
of it.
Yeah, there it is, next to this dot transform.
I have that in multiple spots, cause I have that in both of those. That's the problem with relying so much on the stuff that's giving, it gives you, and I'm not sure why this is coming up right here. Delta time, did I misspell delta time as well?
There's something
It may be a
capitalized.
capital T, I thought it was lowercase, but you may be right. Build, you're right, cool, nice, interactive. Okay, so if I hit play now, I can move it by pressing the right button, and it works. If we turned on gravity, you would see it would fall, but so if you're having that and following along, just turn off gravity on the rigid body of the object. Yes?
Would you need to know the size of the frame to keep it in the frame?
If you wanted to keep it inside of the frame, yes. What you could do, what I've done in my game, it's easier in 2D because the frame's not moving, but if your frame isn't moving, you could just put objects, the edge of the frame, if you know where everything's gonna be, and do that. Otherwise, you would have to get a reference to the frame, write the variables of the size of the frame, and then convert the value in pixels to world coordinates. There are videos out there on how to do that, but yeah, you would have to know the size of the frame. Does that make sense?
Yes.
Alright.
This is a little random, but is there any reason you use this dot in the script instead of, since it's implied on the object, it's actually?
Yeah, so you could completely remove these, and it's up to you basically, or up to your team if that's something your team wants to talk about. You could have it like this, and it's definitely cleaner and simpler. There's none of that going on, but I like to throw the this in there because I'm working with a bunch of different references to objects in this one script. So this one script may want a reference to the gun object if it's a bullet. And so I just want to specify, again, this is here. Again, it's not necessary, even if you have references to other objects, it's gonna work perfectly fine, but I just like adding that extra. Definitely people disagree with me and just leave it off entirely, but it would run perfectly fine now. Is there anything you want to say on that? No. So I'm just gonna add the functionality to the left key as well. So I copied the code I had written already, and then I'm going to add an else if after that first statement. So basically, if the right key is down, pressed, then do this. Otherwise, we're gonna see if the left key is pressed, we're going to do the opposite. We wanna go the opposite direction, which is really simple. We just change the right arrow, dot right arrow to dot left arrow, and then we change this value to basically the negative of this value. And so I'm gonna put a negative sign in front of the 5. And then, unsurprisingly, but we can all figure out what's gonna happen, we can move both directions. But there's a bad programming convention here, bad Unity convention here that we've done. We've hard-coded this value, this 5 value. Like if we create that value higher, it's gonna move faster. If 5 is more like a 2, the object is gonna move slower. And we may not right now know that 5 is exactly what we want. We want to sort of be able to play with it and figure out what speed we want, or if we want to change it later. Obviously, a variable is what we should be doing. We should have a speed variable. Let's just type in float speed, and then at the top, right before the start, underneath the class, public variable. And then instead of 5, we do speed, and then negative speed. That's obviously a good programming convention in general. You want to be using variables instead of hard-coded values if you're going to be using it in multiple places. But there's a special extra bit about this that's Unity specific. So this variable I'm going to set to private. Again, I think it's already private if I don't say that, kept that private word, but it's just a good programming convention. And then ultimately what we want to be able to do is I want to be able to come in here and have options under this script where I can choose dynamically the speed so that I can be looking at this, not going to the script, changing the value, but I can just change it from inside of here. The way to do that is above the private float speed, we're gonna do square brackets, serialize, this is gonna be hard to type because they usually just have it tell me. Serialize field. I believe that's what it is. If it's not, serialize field. It's a hard word. Liable. Is that how you spell serializable, or let me get rid of that?
I think it's serialized field.
I think that's it.
That's what popped up.
Oh, that's what came up for you?
Mm-hmm.
Did I mistype it? Yeah, I did. And you said serialized field?
Mm-hmm.
Okay, sweet, thanks. Serialized field. Capitalize. And there we are. This warning, we don't need to worry about that right now. It's basically telling us that the value speed is not set to a value. But now that we've typed that in, so now that we put right above the private float speed serialized field, that basically tells Unity we need to have access in here. In fact, you can see we've got the speed variable that we created, and it's set to its default value 0. And so if I go ahead and play, the value is going to be 0, so me pressing left and right is not going to change anything. But I can come over to this variable and change it, go back to the scene, and I can move. And I can sort of just play around with this value, maybe set it to 10, click back into the scene to give me control, and it's moving a lot faster. And so this is a far better way of trying to figure out what the speed is that you want the character to move, or what game objects you want to reference, creating a bunch of private variables and creating the serialized field. Just be aware that if you make any changes while you're in play mode to this, then when you go out of play mode, that variable is going to go back to whatever it was before we were playing. So now it's 0. So if we want something to stick, then we make sure we set that value outside of play mode, and that's going to be permanent. If you've been watching a lot of videos on YouTube, they're not going to type in serialized field. Instead, they're just going to create this as a public variable. Because if this were a public variable, you wouldn't need to say this, and you would have access to it in the Unity editor. I used to do that, but that's bad programming practice. Just like you don't want global variables if you don't need them, you don't want public variables if you don't need them, you don't want other scripts accessing those if it's not necessary. So just do this, always set it to private, or leave off the keyword so that it's private, and then type in serialized field. Another small comment is, everyone that I watch in Unity, and what I've been doing since the beginning of me doing Unity, is do floats instead of doubles. So in Java, you've been doing a lot of doubles. Unity prefers floats, and I think it's because they're smaller and it wants to be as lightweight as possible, because games and graphics tend to be heavyweight. So Unity likes floats, and so whenever you're thinking I need a double, do a float instead. Let's see. I feel like there was something else I wanted to say in here. Okay, I'll move on to a different topic inside of scripts. Was there a question? No? I thought I said no. Like I said, there was a few other methods that Unity provides us. So we've looked at the update. We've talked about the start. You can delete start, and it's not going to be a problem since we're not using it right now. There are other ones, such as onTrigger. So it gives me this information. What the heck? OnTrigger enter, OnTrigger exit, OnTrigger stay, and then onCollider enter, onCollider exit, onCollider stay. That was a lot of information, but basically these methods are run when something enters the object's collider. So if our circle or our character square has a collider component on it, and indeed it does right here, and this trigger box is not checked, then it's considered a collider and not a trigger. And that anything written inside of the onTrigger or onCollider exit enter stay methods is going to be run when other objects interact with this. I'm going to show you kind of what I mean about that to explain that a bit better. Because if you're going to have collision, it's usually not good enough to just put colliders and rigid bodies on items. but, you'll also need to put these methods into your code. So I'm gonna create another object. The keyboard shortcuts for changing how you interact with the object in the scene, so that would be moving it around, rotation, and then scaling. Those are WER. So all of these options you have up here are just those QWERTY keys on your keyboard for something for shortcuts. So I'm gonna just make a wall by scaling this along the X and the Y axes. I'm going to come over here and rotate it 90 degrees. Make it facing that direction. Oops. And then I'm going to move it over here. If I go back to the game, I can see, okay, we've got a wall there, and if I hit play, it's gonna move into that wall. Right there. Not colliding or anything. The wall has a collider object on it, or a collider component on it, so we can now implement the onColliderInter feature. We go in here, type in onColliderInter, and we create this component. This script. Like I said, onColliderInter, stay, and exit are all options. Enter runs once when the object enters, when an object enters this object's collider. onColliderStay runs collision stay runs every frame while another object is inside of that, and then exit is like enter but the reverse when an object exits it, that frame when that happens. This, when you're starting to use these methods, that's when you really want your layers to be sorted, as I was showing you earlier, because sometimes you want this to run, sometimes you don't. I'm actually going to backspace this. I think there's another one that I prefer. No, collision. That's collision. Oh, I see it. And then this right here is just the collision that it references. It's So this collision will give us information of like the object that entered this object, or collided with this object, its tag, its data, its components, everything like that. For instance, if I type in, collision info dot game object, that would give me a reference to the game object that collided with this. So what we're just going to do to demonstrate that this works is debug.log, parentheses, again like our current line statement, collision info.gameObject.name, just like the name of the game object that entered this other object. Come back here, see if we get any errors. If I type that right, sweet. All right, remember this script is on this cube right here, this player. And now, we would hope that when this object enters the other one, we get a message inside of here telling us the name of that object. We don't, because our settings are